Okay, so in this second part of raster analysis, we're going to demonstrate and have you work through some other techniques for analyzing and working with raster data. So for example, we can look at values over a moving window. That can be done using focal statistics. So it calculates a statistic within a window of a defined shape and size. So for example, here I've taken an elevation surface and I've converted that into a standard deviation of elevation as calculated in a moving window, which is circular in size and has a radius of 21 cells. So areas that are darker or more deeper red would indicate a greater standard deviation or a higher variability in elevation in that moving window. This is an example of Euclidean or straight line distance. So from each cell, we calculate the distance to the nearest input feature. So in this example, I have some major roads within the state, and I'm calculating the straight line distance from those major roads to each cell. Again, that's Euclidean or straight line distance. Zonal statistics allows you to obtain a statistical estimate by zone. In this case, we're obtaining that output as a raster grid as opposed to a table. So here our zones are defined as the counties in the state, and our output will be a grid where each cell contains the elevation range in this case by county. Note that every cell in the same county has the same code because they store the same statistical value. So for example, all the cells in Randolph County have the elevation range within that county. It is also possible to obtain statistics not as a raster output, but as a table. So here, instead of just getting a single output as a raster grid, we're obtaining a variety of statistical measures by zone as a table. Once this is done, you could then take the table and join it to the zones, for example, the counties, using the common field, in this case the name field, and that will allow you to basically associate the calculate statistics to each individual zone. This is an example of how this is what you're going to work through. So zonal statistics is table. So find the county in the state that has the highest mean elevation. So you'll have to calculate a table of using the counties as the zones, the elevation as the raster, and the mean statistic, and find the one that has the highest mean. If you would like to summarize categorical data like land cover as opposed to continuous data like elevation, you can accomplish that using the Tabulate Area tool. This will provide back a land area in the map units of each of the categories. So this is in a UTM projection, so you're getting back the area of each category in square meters. It's also possible to extract raster values at points using either the extract values to points tool or the extract multi-values to points tool. This slide is demonstrating the multi-values to points tool. So here I have discharge point locations, and at those locations I'm going to extract the raster value from the elevation grid and the land cover grid. And this will be the field name that shows up in the attribute table. All right, so that's an example of producing or extracting values of point locations. This is related to some terrain analysis. So if you have an elevation model or a DM, digital elevation model, you can generate some output from that. So for example, for visualization, you could generate a hillshade, which effectively creates a shaded relief surface by casting shadows over a landscape using a defined sun position. The sun's position is defined using the compass direction, so that's the azimuth, and the height above the horizon, which is the altitude. So this is an example of a hillshade derived from elevation measurements which were produced from LiDAR.